Hello everyone, welcome to my YouTube channel Self Study. Today we will continue the second part of this chapter number 6, heat transfer. So continue the chapter. Effect of temperature on the rate of evaporations. The rate of evaporations increase with the increase in temperatures of liquid. The reasons is that the energy of the molecules increase with increase in temperature. So more and more molecules come to the surface of liquid, hence the rate of evaporations will increase with increase of temperatures. Now, effect of boiling of air on the rate of evaporations. When air is blown above the surface of liquid, the rate of evaporations increase. The reason is that blowing air take away with it the molecules of liquid escaping out of the surface. To take their place, other molecules escape out from the surface of the liquid. Third, effect of increase in area of surface on the rate of evaporations. Means increase in area of the surface, the rate of evaporations. On increasing the area of surface exposed to air, the rate of evaporations increase. Means the surface will increase, the rate of evaporations will also increase. The reasons being that on increasing the area of surface, number of molecules escaping out from the surface increase. Effect of pressures of humidity. In presence of humidity, effect of presence of humidity. In presence of humidity, the rate of evaporations becomes slow because vapor molecules do not find space to escape. Cooling produced during evaporations. When a liquid evaporates, it produces cooling in its surrounding. So what's the reasons of producing cooling during evaporations? Reasons: in the process of evaporations, a liquid changes to vapor, and for this purpose some heat is needed. If there is no external supply of heat, the liquid will draw the necessary heat from its surrounding, and therefore it gets cooled. So what is boiling? Difference between evaporations and boiling. So second is boiling. The change from liquid state to the gaseous state on heating at a constant temperatures is called boiling. Means boilings will at constant temperatures. The temperatures at which the liquid change into vapor without further increase in temperatures is called the boiling point of the liquid. The boiling of a liquid can be demonstrated activity with the following activity. Activity number 1, I will discuss it later. Now, explanations of boiling by molecular motions. When a certain liquid is heated, there is a rapid formation of vapor from all part of the liquid as indicated by visible bubble. Heating of the liquid increases the average kinetic of energy of the liquid molecules. When the molecules acquire sufficient kinetic energy to do work against the force of attractions of other molecules. Thus, these molecules now start leaving the liquid not only at the surface but also near the wall of the container. Means when you boil the water, you see a visible bubbles is there on heating the liquid. This bubbles escapes out of the surface when you get extra heat. This is shown by the presence of bubbles on the wall of the vessels. The bubbles grow in size with further evaporations and move to the surface in quick successions. This causes agitations in whole of the liquid, and this is called boiling. When the boiling starts, the temperatures of the liquid does not increase any further. This temperature is known as boiling point of the liquid. Means when the liquid start boiling, the temperature does not increase any more further, and this temperature is known as boiling point of liquid. Now, effect of pressures on the boiling point. The boiling point of a liquid increase with increase in presence pressures, and it decrease with decrease in pressures. Means if you increase the pressures, boiling point will increase, and if you decrease the pressures, boiling point will decrease. The reason is that at the boiling point, the pressures exerted by the vapor of liquid is equal to the atmospheric pressure. Thus, the boiling point of a liquid depends on the surrounding atmospheric pressures. With the increase of atmospheric pressures, boiling point of a liquid increase to increase the vapor pressures and make it equal to the atmospheric pressures. And with the decrease in atmospheric pressures, it decreases. This is why the mountains where the atmospheric pressures is low, in mountain atmospheric pressures is low. water boil at temperature below 100 degrees Celsius, means in mountain water boiled below 100 degrees Celsius and it become difficult to cook the vegetables. On the other hand, in pressure cooker, by keeping the water vapor inside it, the surrounding pressures increase, then water inside it boil at a temperature nearly 125 degrees Celsius, means how difficult for the mountain. So the vegetable get ready cooked inside it. Difference between evaporations and boiling. In both process, evaporations and boiling, a liquid change into state to the vapor or gaseous state, but they different in the following respect. Number 1. Evaporation take place at all temperatures, while boiling take place at a fixed temperature called boiling point of liquid. Number 2. Evaporations occur only from the surface of liquid, while boiling take place throughout the mass of liquid at the same temperature, same instant. Number 3. In evaporations, some molecule near the surface of liquid acquire sufficient kinetic energy by collisions with the other liquid molecules to overcome the attractive force of other molecules, thus absorbing heat from the surrounding. They escape out in space. On the other hand, in boiling at a fixed temperature, the average kinetic energy of the liquid molecules becomes sufficient to overcome the force or attractions of other molecules, and they start leaving the liquid throughout the mass of liquid. As a result, bubbles are formed. This bubble move to the surface and boiling of liquid take place. Number 4. In evaporations, heat is absorbed by the molecules at the surface of liquid, means heat is absorbed by the surface of liquid in evaporation from its surrounding, so as to change to vapor state, while in boiling, heat is supplied externally at a fixed temperature. Number 5. Evaporations is a slow process, while boiling is a rapid process. What is thermal expansions? Now, it has been experimentally observed that when a substance is heated, it expands, and when it is cooled, it contracts. We will now consider the thermal expansions in solid, liquid, and gas separately. Means when a substance is heated, it expands, and when it cooled, it contract. This is called thermal expansions. Thermal expansions in solid. A solid has a definite shape. When a solid is heated, it expands in all directions. Hence, the length, area, and volumes all increase on heating a solid. The increase in length of solid is called linear expansions. Means when length is increased, is called linear expansions in solid, and when area of the increase in area is called superficial expansions, and increase in volumes is called cubical expansions. Explanations of thermal expansions of solid on the basis of molecular motions. On heating a solid, the average kinetic energy of molecules of the solid increase. They start vibrating about their mean positions with a large amplitude. The result is that their mean positions change such that the intermolecular separations between the molecules increase. Thus, the solid expand equally in all directions. Demonstrations of thermal expansions of solid. Now, the thermal expansions in solid can be demonstrated by the following experiment. Let's see the experiment. Experiment number 1. Point number 1. Take a ball and ring setup. This shown in figure 6.3a. Ball and ring setups. The metal ball just slip through the ring when both are at the room temperature. Means when ball and ring are at room temperature, the ball gets slip. Now heat the ball on a burner and place it over the ring. You will notice that the ball does not pass through the ring. The reason is that on heating, the ball expands and become bigger in diameter than the ring, and now after heating, the ball does not pass through the rings, as you see. Number 3. Now allow the ball to cool by itself, and after some time again place it over the ring. You will notice that the ball now passes through the ring. This is because on cooling, the ball again contract. Experiment number 2. Take a bar and gauze setup as shown in figure 6.4. It consists of a metal bar and a metal gauze. Both are in metal bar and metal gauze. The bar just fit into the gauze when both are at the room temperature. Means bar just fit into the gauze when both are at the room temperature. Now heat the bar and try to fit it into the gauze. You will find that it does not fit into the gauze now. This is because the bar expands on heating and become longer than the gap provided in the gauze. Means after heating the bar, it is very difficult to fix in the gauze. Now allow the bar to cool it by itself. You will find that the bar contract on cooling and again fit into the gauze. What is linear expansion? When a solid in the form of a rod is heated, only the linear expansion is effective. The increase in length of a metal rod on heating depend on the following three factors: original length of the rod, increase in temperature, and material of the rod. Now dependence on the original length of the rod. If we heat two rods of the same metal, one short and the other long, to the same temperature, you will find that the long rod expands more than the short rod. Thus, longer rod greater in the increase in its length. Dependence on the increase in temperature. If we heat two identical rods, one at a higher temperature than the other, means different temperatures, we find that the rod heated to the higher temperature expand more than the rod heated to a lesser temperatures. Thus, more the increase in temperatures of rod, greater is the increase in its length. Dependence on the material of the rod. If we heat two rods of the same length but one of the copper and other of iron at the same temperature, you will find that the copper rod expand more than iron. You will find that copper rod expand more than iron. The increase in length of copper rod is nearly 3 by 2 times the increase in length of the iron rod. Thus, the increase in length of a rod depend on the material of the rod. Means increase of length depend on the material of the rod. If L naught is the length of a rod at 0 degree Celsius, and if its length is T degree Celsius and is LT, the increase in length is given LT minus L0 is equal to L0 alpha T, where alpha is the coefficient of linear expansions which depend on the material of the rod. Alpha is different for different substance, so it can be changed. Its unit is per degree Celsius. The value of coefficient of linear expansions of some metals is given. So value of coefficient of linear expansions of aluminium is 24 into 10 to the power minus 6 per degree Celsius, brass 90, copper 70, steel 30, iron 12, invar 0.9 into 10 to the power minus 6 per degree Celsius. It's very important, learn it. Note, invar is an alloy which almost does not expand on heating. This is why pendulum of a clock is made up of invar. Means pendulum of a clock is made up of invar. Second, Pyrex glass also expand negligible on heating. Pyrex glass is also expand, means almost negligible on heating. Linear expansions of activity number 2 and activity number 3, I will discuss it later. So thank you for today. Please subscribe to my channel for the next part. Thank you.